Three trigonometric ratios are the sine, the cosine, and the tangent. For any angle theta, the sine, the cosine, and the tangent are given as the sine theta is equals to opposite side over hypotenuse. The cosine theta is equals to adjacent side over hypotenuse. Tangent theta is equals to the opposite side over adjacent side. Now let us illustrate. Look at this illustration 1. Given that sine 90 minus x degrees is equals to 0.6, where x is an acute angle, find without using mathematical table the value of tan x. Now, how do you go about this? If this triangle is right angle triangle, this angle is 90. Now, if this angle is x degrees, definitely this angle must be 90 minus x degrees, because the remaining two angles must add up to 90 degrees. Now, sine 90 minus x degrees is equal to 0.6. If we write this 0.6 into a fraction, we get 6 over 10. Now we know the sine is equal to the opposite side over the hypotenuse. Now this means that the hypotenuse, the longest side, is 10. The opposite side with respect to this angle 90 minus 6 is this one, so the opposite side is 6. Like that. Now, what about finding tan x? Tan x degrees, we shall reference this side. So the opposite side shall be this one, while the adjacent side is this one. Now using Pythagoras theorem, we can find what is this opposite side. So it will be 10 squared, the hypotenuse squared, this adjacent side squared, and then we get the square root. This gives us 100 minus 36, then we get the square root. And this gives us 6, 4. We get the square root of 6, 4, which is 8, meaning that this side is 8. Now tan x is the opposite side over adjacent side. Now we know the opposite side is 8, the adjacent side is 6, meaning that tan x will be equal to 2 goes into 8 4 times, 2 goes into 3 into 6 3 times, so that we have 4 over 3, 4 over 3, which is the same as 1 and a third. Given that x is an acute angle and cos x is equal to 2 into the square root of 5 all over 5, find without using mathematical tables or a calculator tan 90 minus x. Now, cos x degrees is equal to 2 into 5, the square root of 5 all over 5. Now we know cos theta. Cos theta is given as the adjacent side over the hypotenuse. Now it means that if this is x, the adjacent side will be this one, 2 into the square root of 5. Then the hypotenuse will be this one, 5. Now using Pythagoras theorem, we can calculate the remaining side. We get 5 squared less this one, 2 into the square root of 5 squared, and then we get the square root. 5 squared is 24. 2 multiplied by 2 we get 4, and then 2 multiplied by the square root of 5 we get 5. So 4 multiplied by 5 we get 20. So 20, and then we get the square root. So we have the square root of this 25. 5 squared is 25. 25 minus 20, we get the square root of 5. Square root of 5. Now, this is a right angle triangle. If this angle is x, this angle is 90 minus x, because the two remaining angles must add up to 90. So if you have x, the next should be 90 minus x. Now, tan 90 minus x degrees is equal to the opposite side, which is this one, opposite side over adjacent side. So the opposite side to this angle is 2 into the square root of 5. The adjacent side, this one, is the square root of 5. So this one cancels this one, meaning that tan 90 minus x degrees is equal to 2. Assume this is an equilateral triangle, x, y, z. Each of this angle is 60 degrees. Now, if we drop the perpendicular bisector from x to bisect y, z into equal side, into equal length, it will also bisect this angle into 30 degrees on either side. Now this becomes the height. Assume this triangle is 2 units, every side is 2 units, so this bisector will bisect this side into 1 unit on each side. Now we can find the height using Pythagoras theorem. Now the height will be the hypotenuse squared, this 2 squared, less this side squared, which gives us 4. We get the square root, which gives us 4 minus 1, which is equivalent to 3, the square root of 3, like that. So the height here is the square root of 3. Now if we are to get sine 30 degrees, it is the opposite side over the hypotenuse, so it is 1 divided by 2. What about cos 30? Cos 30 will be the adjacent side over the hypotenuse, so the adjacent side is the square root of 3 over the hypotenuse, which is 2. What about the tangent? Tangent will be the opposite side over the adjacent side, which is 1 all over the square root of 3. Now suppose you divide the sine and the cosine, you will be sure to get 1 all over the square root of 3. Now let's look at sine 60. Sine Sine 60 becomes the opposite side, that's the square root of 3 over the hypotenuse is 2. Cos theta becomes the adjacent side, that's 60, so the adjacent side is 1, the hypotenuse is 2. And tan theta, that's 60, that's the opposite side over the adjacent side, that is the square root of 3 all over 1 is just the square root of 3. Now divide the sine and the cosine, you are sure to get the square root of 3. Now you realize that when you divide the sine and the cosine, you get the tangent. Now you can calculate that for sine 30 is equals to cosine 60, and cosine 30 is equals to sine 60. And we are using the same triangle. This is the part of the triangle we are using. So this means that sine, assuming this angle is x, because this is 90 degrees, assuming this angle is x, so sine x will always be equal to cos 90 minus x, the opposite. So if sine x is 60, it will also be equal to cos 30. That's why you can see this and this is equal, this and this is equal, and the relationship is vice versa. We had illustrated the relationship between the sine, the cosine, and the tangent using an equilateral triangle. Now let us use a right angle triangle that is isosceles. So with sides 1, 1. So you can find the hypotenuse using the Pythagoras theorem by squaring 1, 1, add, then find the square root. So the hypotenuse is the square root of 2. Now if we were to find sine theta will be the opposite side of a hypotenuse, giving us 1 all over the square root of 2. Cos theta will also be 1 all over the square root of 2, because the adjacent side and the opposite side are equal. What about tan theta? Tan theta will be 1. Now divide cosine theta and cos theta, you get 1. This reinforces that when you divide the tan and the cosine, you get the tan. And if this is the sine, the cosine will be this. If this is the cosine, the sine will be that. To illustrate the relationship between the sine and the cosine, we have this equation: sine 3x degrees is equals to cos 2x degrees. Now sine 3x degrees is equals to cos 2x can be written as sine 90 minus 2x degrees. Now we can drop the sign and remain with 3x degrees is equals to 90 minus 2x degrees. So can just move the bracket so that we collect like terms. So this, we add 2x on both sides, so we have 5x is equals to 90, and then we divide 5 on both sides, we have x is equals to 18 degrees. Now solve for x. Sine 2x minus 15 is equals to cos 3x. Now sine 2x minus 15 degrees is equals to cos 3x degrees. Now sine 2x minus 15 degrees can be written as, this will be sine 90 minus 3x degrees. Now drop the signs. We have 2x minus 15 is equals to 90 minus 3x. Now collect like terms, or we can do it like this: add 3x on both sides, so that we have 5x minus 15 is equals to 90. Then add 15 on both sides, we have 5x is equals to 105. Then divide 5 on both sides, we have x is equals to 21 degrees. For acute angles which are between 0 and 90 and lie in this quadrant, let's name it as the first quadrant, all the sine, cosine, and the tangent are positive. But now for other quadrants, like if we went into this quadrant, up here the angle will be 180, up here is 270, up here is 360. We have made a complete revolution. What will be the cosine, the tangent, and the sine for the angles in the other quadrant? It means we have left acute angle, we are dealing with angles greater than 90. Now, you remember the book in the Bible called Acts. If you write like this, Acts, like that, you are able to memorize that in the second quadrant, only the sine is positive, the tangent and the cosine are negative. In the third quadrant, only the tangent is positive, the sine and the cosine are negative. And in the fourth quadrant, only the cosine is positive, the sine and the tangent are negative. For angles greater than 360, for the sine, the cosine, and the tangent, remember 360, we are making one complete revolution. So depending on the quadrant that the angle will fall, after making a complete revolution and the angle falls in the first quadrant, or the trigonometric ratio will be positive. If it falls in the second quadrant, only the sine will be positive. If we make a revolution and it falls in the third quadrant, only the tangent will be positive. And if we make a revolution and fall in the fourth quadrant, only the cosine will be positive. What is sine 5 over 2 theta is equals to half between theta is equals to 0 and 180 degrees. Now we can write this equation as sine 5 over 2 theta is equals to sine 30. Because sine 30 is what we get to be a half, we can also write it as sine 150 is what we get as a half. We can also write it as sine 210 degrees. We can also write it as sine 330. Now we have from in the first quadrant 30 is 0.5. The second quadrant 150 is 0.5 is for sines, and the third quadrant 210 is 0.5, but remember it's negative, so we don't need this because it's positive, so we only need positive values. In the third quadrant 330 is 0.5 but negative, so we don't need this. So it will mean we have to make a complete revolution again to go back to quadrant one. Now that means we shall add 30 on 360, so we shall have this as 390 degrees. Also, we make another complete revolution. We go to the second quadrant, that is 360 plus 150, giving us 510. So those are the values for sine 5 divided by 2 theta is equals to a half. We can make as many revolutions as we want, but we have been limited. Theta should be between 0 and 180. Now let's calculate and see. So we have sine 5 over 2 theta is equals to sine 30 or sine 150 or sine 390 or sine 510. Now do the signs so that we have, so we get 30 multiplied by 2 over 5 is 12 degrees, 150 by this is 60 degrees, 310 by this is 156 degrees, and 510 by this is 24 degrees. But we have been limited. Our theta should be, if we track triangle x, y, z to right triangle, and this angle is x, we can get the hypotenuse by squaring this side and squaring this side using Pythagoras theorem. So using Pythagoras theorem, it means that xy squared plus yz squared is equals to xz squared. Now recall that sine x is equals to opposite side over hypotenuse. Now the opposite side is xy, the hypotenuse is xz. Also recall cos x is equals to the adjacent side over hypotenuse. The adjacent side is yz, the hypotenuse is xz. Now having this in mind, let's divide xz on both sides. So we have xy squared divided by xz squared plus yz squared divided by xz squared is equals to 1. Now you can place that xy and xz is this one. So here we have sine x squared plus, you can place it this one is this one, but this square, this one square, plus cos x squared is equal to 1. We can also write like this, sine 2x plus cos 2x is equal to 1. That's the relationship between cos 2x plus sine 2x is equal to 1. That's how it's derived. In this circle with the center O, we have this radius, and we have a arc xy. Now, when arc xy is equal to radius and arc xy subtends an angle theta at the center, this angle theta is equal to 1 radian. Now, remember, the total angles at the center is equal to 360. Now, if you divide 360 by theta 1 radian, we should have the 360 degrees is subtended by the circumference, which is given as 2 pi r, and theta is subtended by arc x, y. Now, 2 pi r is divided by arc xy, which is equal to the radius. It means that this r and this cancel so that we have 2 pi. Now, this reinforces the notion that if you have 2 pi multiplied by theta, you should get 360 degrees. And since theta is equal to 1 radian, it means that 360 degrees is equal to 2 pi radians. Now, since 2 pi radians is 1 revolution, or a circle like that, it's always denoted as 2 pi c. 2 means 1 revolution. Now, if you divided 360 degrees and 2 pi r, you get 1 radian, which is approximately 57.3 degrees. Let's assume triangle ABC is an equilateral triangle. Now we shall take length AB to be C, we shall take length BC to be A, length AC to be B. Now since it is an equilateral triangle, we can drop the height of this triangle from any of the vertices A, B, C, such that we have the height AY, we have the height BZ, and we have the height CX. Now, how can we find the area of this triangle? We can find the area of this triangle using any of its height. Now let's say area. We know area of triangle ABC is equals to a half base height. Now we have a half. Let's use the base of AC, the base of the base as AC, the base as AC, and then this means we shall have to multiply with the height BZ, the height BZ. These are the base, the height will be BZ, so the height will be BZ. Now we have our half. We said our AC should be B, and we can find BZ using sign A, while C becomes the hypotenuse. So BZ, the height will be C sine A. That's one way of finding the area of the triangle. That's one. Secondly, we can find the area by having a half multiplied by the base. Our base will be BC. Our base can now be BC. If this means the height will be AY, the height will be AY. Now let's equate what we know. BC is A, and AY is B sine C. We use C at this angle C, and so it should be B sine C. Another way, this is the second way. Another way of finding the area of this triangle will be a half AB multiplied by CX. So CX is now the height, and then AB is the base. We can equate what we know. AB we agreed it to be C, and CX you can use A sine B to find the area. So this gives us the third equation of finding the area of this triangle. It is an equilateral triangle, so any of these heights and any of its length can be used as the base. Any of this length can be used as the base, and any of the heights. That's why we have come up with these formulas for finding the area of this triangle. Now, suppose we equated 1 and 2. We equate this 1 and 2. We equate them so that we have a half. What is 1? 1 is a half B C sine A is equals to, because all of this we get the same thing, so is equals to the second one is a half AB sine C. Now if you get it like that, you can see a half is on both sides, B is on both sides, so they cancel each other, so that we remain with C sine A is equals to A sine C. Now divide each side by sine A. We remain with the C is equals to A sine C over sine A. Now divide each side with sine C. We get C all over sine C is equals to A all over sine A. So that is our fourth equation. Now let's equate this equation, the second one, and the third one. If you equate the second one and the third one, we get this is a half AB sine C is equals to a half AC sine B. Now you can see a half is on both sides, A is on both sides. So what we remain with is the constant remaining is B sine C is equals to C sine B. Now divide each side by sine C. We remain with here B is equals to C sine B all over sine C. Now divide each side by sine B. We get B sine B is equals to C sine C. Now the next step, combine. This is our equation 5. Combine equations 4 and 5. Combine the two. If we combine, we will definitely get A over sine A is equals to B over sine B is equals to C over sine C. This is now what we call the sine rule. Though I've used the equilateral triangle, it's applicable for all triangles. Let's assume triangle ABC is an isosceles triangle, or any other triangle which you can drop the height like AD. Now, let's side ABBC, let's side BCBA, let's side ACBB, and side DCB equal to X. Now, using Pythagoras theorem, we can find AD. What is AD? We say AD squared is equals to, now AD squared. Now you can use any of this as hypotenuse, any of this as a hypotenuse, and any of this as the base. Now, suppose I used AB as the hypotenuse, so you can say it's equals to AB squared less BD squared. Now, we have said AB should be equal to C, so you can say C squared less BD is a fraction of A, so BD will be A minus X, like that. Now we can expand X. How to expand X? You can say X minus A minus X. You can expand AX. Sorry for that. Talking wrong. AX like that, multiplied by AX. and then put here a, put here negative x, so that when you multiply this you get a squared minus ax. When you multiply this you get ax minus plus this negative, and this makes this to be plus x squared. Now let's simplify because these are the same, so we have a squared less 2ax plus x squared. So that is how we expand this part. So let's go back to our equation. So is equals to c squared minus a x squared. Now remember, there's a negative here, so this negative will affect this, so it will be plus 2ax, and then this negative will affect this, so less ax squared. That's our first equation. Now we can also find AD squared using the other side. So AD squared will be equal to AC squared, will be equal to AC squared minus DC squared, That's using Pythagoras theorem. Now we know AC is equals to B, so squared, minus DC is equals to X, that is X squared. That is our second equation. Now let's go on. We can equate equations 1 and 2 because it is they are all relating to AD squared. So this means AD squared can be equal to this or this. Now equate them. So we have c squared minus a squared plus 2ax minus x squared is equals to b squared minus x squared. Now that's equating them. Now remember, this and this are like terms and they are equal on the opposite side, so it means they cancel. So what will remain is c squared minus a squared plus 2ax is equals to b squared. Now make c squared the subject of the formula. If we made c squared the subject of the formula, we get c squared is equals to a squared plus b squared minus 2ax. But remember something. Cos c, this cos c will be equal to adjacent side which is DC all over hypotenuse which is AC. So cos c will be equal to DC over AC. And DC is X and AC is B. Okay. Now having known that, it means that this X is equals to B cos C. Now equating into this equation for the values of X, we put B cos C. So what we have now is this equation: C squared is equals to A squared plus B squared minus 2AB cos C. If we made B squared the subject of the formula, we shall get A squared plus C squared minus 2AC cos B. So this is our first equation. This is our second. This is our third equation. This is our fourth equation. Now, if we made A the subject of the formula, we get B squared plus C squared minus 2AB cos A, and this is our fifth equation. Now, these three equations, they are what we refer to as the cosine rule. Though I've used a triangle that we can drop a perpendicular, let's say it's an isosceles triangle or any other, the sine rule is applicable to any other triangle. Trigonometric graphs. We have the sine graph, which is normally written as y is equals to sine x. It's also called the sine wave. The wave repeats itself after every 2 pi radians. Now we also have the cosine graph, normally denoted as y is equals to cos x. It's also called the cosine wave. It repeats itself after 2 pi radians. Now the maximum possible distance a curve reaches from the x-axis is known as the amplitude. You can see this curve from the x-axis, the maximum is 1. From the other side, you can see the maximum is still 1. We ignore the negative. So the amplitude of this curve is 1. Normally, this displacement 1 is measured in meters. Now look at this curve. The maximum possible displacement from x is 1, 1, 1. So that's the amplitude of this curve. Now the interval at which the wave completes one circle or repeats itself is the period. So you can see that this curve starts from here, goes like that, and then starts from, now reaching it is starting to repeat itself. So this interval 0 to 360, that is just 360 degrees. It is the period of this curve. Now you can see this curve starts from here, goes like that, and reaches here. So from here it will be repeating itself. So also the period for this curve is 360 degrees. Now the horizontal distance or length of one wave when the wave completes one circle is the wavelength. Now we agree that this wave completes a circle from 0 to 360. So this distance from 0 degrees to 360 is the wavelength. The wavelength is also normally measured in meters. Now this wave starts from here up to it completes one circle. So this is the wavelength. Remember I said this is the amplitude. This is the amplitude. So that's something about the sine and the cosine waves. The tangent curve, also given as y is equal to tan x, is discontinuous after every 90 degrees. After every 90 degrees, the graph approaches the line x is equal to 90, but never touching it. The lines, these lines of the graph are also referred to as asymptotes. Now, the amplitude, we say it is the maximum displacement from x-axis of the curve. You can clearly see that the amplitude of this curve will vary with the angle. If it is 60, you can see the amplitude is small. If it's 90, the amplitude is infinity. If the angle is 0, the amplitude is 0. So the amplitude will vary with the angle. Now, having learned all about trigonometry, can you see if you can attempt this quiz? Quiz 1. What are the values of theta for theta being between 0 degrees and 360 degrees, satisfying the equation 5 sine theta is equal to -4? Question 2. If cos 2 theta is equal to 0.8070, find theta when theta is between 0 degrees and 180 degrees. Question 3. Solve the equation 8 sine squared theta plus 2 sine theta minus 3 is equal to 0 when theta is between 0 degrees and 180 degrees. Question 4. Solve 3 tan squared x minus 4 tan x minus 4 is equal to 0 when x is between 0 degrees and 180 degrees. Question 5. Find in radians the value of x in the interval 0 radians to 2 pi radians, for which 2 cos squared x minus sine x is equal to 1. Leave the answer in terms of radians. Solve the equation cos 2 theta is equal to sine theta for the values of theta between 0 radians to pi over 4 radians. Leave the answer in terms of pi radians.